Climate change is one of the major global challenges of our time. At the same time, we are facing a paradigm shift triggered by the Russian war on Ukraine. The vulnerability of our energy and resource supply has become particularly obvious in spring 2022. The high energy prices are having a dramatic impact on society and the economy, on top of the already difficult economic situation due to the pandemic. To address these challenges, the role of the European Union is of utmost importance. To present a clear vision of the future of the energy system and create a basis for discussions, TransnetBW has published the study Energy System 2050 towards a decarbonised Europe. The study considers European climate neutrality in 2050 as a target scenario and uses a detailed model to compare two cost-optimal paths to reach the ambitious goals. The first path relies on a global market with gas imports from outside the EU, and the other develops an increasingly energy-resilient Europe. The results show in detailed analyses how to achieve climate neutrality by 2050 by taking measures in each sector: renewables, heating, transport, industry, and particularly the electricity and gas grids. In this study, we assume that the European Green Deal is established, which means that Europe's energy system must become climate neutral by 2050. We have used an energy system model that provides a cost-optimal path for a climate-neutral Europe. The modelling covers most European countries and considers almost all energy demand from the electricity, heating, transport and industry sectors. To achieve this goal, we present two central scenarios: Global Markets, GM, and Energy Resilient Europe, ERE, which consider different developments in boundary conditions for climate-neutral hydrogen production and availability. Today, we have an electricity demand of about 2,500 terawatt-hours in the EU 27. In the future, new consumers from the heat, transport and industry sectors will lead to an increased demand for electricity. By 2050, this electrification will more than double the demand for electricity to 5,500 terawatt-hours. To build a sustainable and cost-efficient system, flexible consumers and storage facilities must integrate electricity generation from variable renewables. The heating, transport and gas sectors have enormous potential for demand-side management and for storing electricity, heat and gaseous energy sources. By coupling the sectors, flexibility in electricity demand can be substantially increased. For example, batteries of electric vehicles can be charged when renewable energies are abundant and discharged in shortage situations to provide electricity. We observe that missing flexibility to and from the transport sector calls for alternative flexibility options which are characterized by much higher cost. It appears that vehicle-to-grid and demand-side management may play a relevant role in efficient future energy systems. Massive expansion of wind and photovoltaic is necessary. There will be a 5-fold increase in wind up to 900 gigawatt and 15 to 18-fold increase in photovoltaic up to 2,300 gigawatt in the EU. There will be strong regional variations in wind and PV generation due to specific local meteorological conditions. Italy and the Iberian Peninsula will predominantly generate electricity from PV, over 75% of power generation, whereas the British Isles, Denmark and the Netherlands will largely use wind turbines. To balance out temporary and regional variations in supply and demand and connect solar and wind generation locations with high load centres, the electricity grid interconnection capacity in the EU 27 needs to almost triple to 200 gigawatt. As a result, international electricity trade will also triple. And that brings many advantages. Through more trade and interconnection of the European market applies to electricity and gas, the energy transition becomes more favourable for all. As a result of the increasing electrification of the energy system and the expansion of renewable power plants, the energy transition results in fewer imported energy carriers. About 75% less energy carriers such as oil and gas will be needed, which means Europe will become significantly more independent of imported energy carriers. A detailed analysis of the electricity grid shows massive congestions throughout Europe. That means that an extensive development of the electrical grid in Europe is necessary. For our control area in Baden-Württemberg, we have already taken a first step in this study. We have defined measures that will be necessary by 2050 to meet the requirements of the energy transition. Besides making electricity demand more flexible through sector coupling and use of storages, innovative electrical equipment enables an optimized utilization of the electricity grid. HVDC converter stations and phase-shifting transformers allow a higher degree of utilization of the future grid through the targeted control of power flows. Weather-dependent dynamic line rating will facilitate a significant increase in grid utilization due to real-time measurement of weather conditions. If these measures are applied to the German grid, the congestions seen in the reference grid will decline by around 25% without any further grid expansion.